Welcome to qnawire.
Hi, so in this case what we have is the following reaction. We have C2F4, which corresponds to carbon-carbon double bond with 4 fluors attached to it, that is going to react with HF in order to produce CF3, single bond, carbon, lower fluor, and 1 hydrogen over here. So the way that we can estimate the enthalpy for the reaction in terms of the bond energies is the following. The enthalpy for the reaction will be equal to the sum of the bonds that are being broken minus the sum of the bonds that are being formed. So, first of all, let's list what bonds are being broken. We're breaking an hydrogen fluor bond. We are breaking as well a carbon double bond carbon, because this is changing from a double bond to a single bond. And the bonds that are being created are one carbon fluor bond, a carbon hydrogen bond, and a carbon carbon bond. So, if we look at the table that you provided, the hydrogen HF bond corresponds to 568 kilojoules per mole. The carbon double bond carbon is going to be 620 kilojoules per mole. And in the case of the bonds that are being created, carbon fluor corresponds to 450 kilojoules per mole. Carbon hydrogen corresponds to 414. And finally, carbon carbon corresponds to 347 kilojoules per mole. So with this information, we can take the sum of both of them. In the case of the bonds that are being broken, the sum is equal to 620 plus 568, simply 1188 kilojoules per mole. And in the case of the bonds that are being created, we have 1211. This means that my delta H for the reaction is equal bonds broken 1188 minus bonds created 1211. All of this in kilojoules per mole, giving us a final result of minus 23 kilojoules per mole. And that would be all. Thank you very much.